Okay, we're going to start working through the review for the hypothesis test review, so Unit J. And I have started a Google Jamboard. I'll have a link to it in the review as well. All right, so looking at, scooch this over a little bit. It's a little hard to see. I just realized some of my words are over there. Okay. So a hypothesis test is the following. So basically what a hypothesis test is we take data from a sample and we try to understand the population. So it's an inferential technique that uses information. Oh, we're not trying to predict a sample. We're going to use information from a sample to predict, infer about the population. So we'll scroll down to the bottom. You're like, oh no, there's a lot here. There is. Submit for testing, and voila, there you go. So make sure that when you say what a hypothesis test is, it's about using the sample to describe the population. The null hypothesis is the following. Is denoted by H1, is always stated in terms of sample statistics. It states that the treatment has no effect. Basically, the null assumes that there is no effect, nothing new, all right? And we tend to say H naught, not H1. And we never put it in terms of sample statistics. It's always about the hypothesized value. There you go. Voila. A z-score is basically your test statistic. All right, so level of significance is alpha, but your z-score is your test statistic. And that's 3 down. A type 1 error, and I have that up here on the slide here. Type 1 error is defined as rejecting the null hypothesis and going with the alternate when the null is true. It is not a student or math error. It's just because you got an unlucky sample. Okay. So a type 1 error is when you reject a true null hypothesis. And a type 2 error is when you fail to reject a false null hypothesis. And again, those notes right there hopefully are pretty clear. Type 2 is when, the way I like to describe it is you have two hypotheses. The null is the first one and the alternate's the second one. Type 1 error is when the first one's true, but you think it's the second one is true. And a type 2 is when the second one's true, but you think the first one's true. Okay, this is going off screen, so let's go ahead and move that way. When testing mu, how do we decide whether to use a standard normal or a student's t-distribution? So basically, mu is for means, and we tend to use the student's t-distribution, all right? If we know sigma, then we use standard normal, but that almost never happens, all right? But this is basic, so, but with the same conditions in unknown sigma, which is what we do use, we use the student's t-distribution, and our rule is 30. So again, and actually if you look at the third slide is about means. For means, if sigma is unknown, we use the student's t-distribution. And I think, is it number 6 I just did? Oops, so I clicked the wrong one. Number 6. Oh, yeah. I haven't done that one. I clicked the right one. So this one is really not very common that we're going to deal with where we use the standard normal. Most of the time we are using student's t. What do we mean when we say a test is significant? Does this necessarily mean the results are important? It just means we see a difference. Remember when, if let's say you did a program on the SAT to raise your test score, we could do a hypothesis test and say, oh, the test score really did go up on average, right? However, that doesn't mean it went up by a lot. So a significant test means we do reject the null, but that doesn't mean that the changes are practically significant. Got it? So it just means they're different. Doesn't mean that, oh, wow, there's a huge difference. I mean, that the difference is going to make a meaningful difference. All right, so let's go ahead and get onto a hypothesis test here. And I'm going to have to widen this again. Okay, So Professor Jennings claims that only 35% of the students at Florida College work while attending school. So you can see the 35%, so I'm thinking it's a proportion. Let me go ahead and continue reading. Dean Renata thinks the professor has underestimated the number of students with part-time or full-time jobs. A random sample of 80 students shows that 37 have jobs. Does the data indicate that more than, we'll have to keep that in mind, of the students have jobs? Use a 5% level of significance. So we can actually, we know, 5% level of significance. 0.05, claim that easy one. All right. So do you see how you have P's here? And so the easiest way, if you get confused, is to look at your hypotheses choices. They're nice. They don't mix out. They do mix in a mu. Oh, it is half P and half mu. I lied. I was thinking they only had P's here. So this is a proportion. How can I tell? Because I have 37 jobs and 80 students. So what we're looking for on proportions is you have X successes and a sample size. And the way you can tell it, we use the one categorical variable stapplet. And so if I look over here, I have these frequencies. I have these counts I have to do. All right. So let's go ahead and get that set up. In this case, we're looking at jobs. Right? Did I say jobs? I sure did. Jobs. And we have a random sample of 80. Can't use that. That's the total. Okay. 37 do have jobs. And then I'm going to say the rest don't have jobs. No job. Right? Okay. So how do I figure out the last part? Well, my total is 80. I take away the 37. So that's going to give me 43. You can't, sadly, type in the subtraction like that. You have to do it on the side. So you hit Begin Analysis. And then you scroll past the data. We don't need that. And we'll get to, we're going to be doing, because this is our testing unit, guess what? We're doing the test. And so what are we worried about? More than 35% of the students have jobs. So equals is always the first one. Look for P equals, and then more than 35%. We are doing proportions. On this unit, sometimes they have 5, but usually it's 10. So either one, just make sure that both these counts are the greater than, not the less than. And just make sure you have the right distribution. So if you look at the Jamboard, let's see. Oh, I don't think I listed it. Basically, if NP and NQ are greater than 10. It says 5, but in AP Stats we use 10. So you'll see either one of these numbers, all right? We use a standard normal, so you can see there's the standard normal. This is proportions. Okay, what is the value of the test statistic? We'll go back here. One sample z-test. You got to look at this, your alternate hypothesis, to figure out your alternate hypothesis here. Here it's greater than, and then you put that 0.35. That's right next to the greater than. Perform inference. So the test statistic is 2.1096, and the p-value is 0.0174. Now notice that this has different values it can take, different directions, and if you don't have the right direction and the right number there, you'll probably, well actually if you don't have the right number there, then both of these will be wrong. If you have the right test statistic, but this is wrong, it's because this part is wrong, okay? And then, which way are we going? We are going greater than. So you look at the curves and you go, oh, which one says greater than? That one. And because our p-value is low, we're going to reject the null because the data are significant. There is sufficient evidence. So these all go together, and I have that on the first slide, which is your basic conclusion. If the p-value is less than alpha, we reject H naught. We have sufficient evidence for the alternate hypothesis. The data is significant. All right, so, and let's go ahead and submit that. Oh, all good. All right, let's go ahead and go to the next one. So here you have an X bar and an S. Notice on hypothesis, I have no X bar. I have no S. So that means we want the means. So we're going to have X bar and S here. Oops, that's proportions. Let me go back to means, right? So we have an X bar and we have an S. So that means we're doing a mean. So we're on this slide. What is the level of significance? Ooh, it's tiny. It's not the 0.05 this time. It's 0.01. We are, it's not going to be a P because we're doing a single mean. And our hypothesized value is 0.8. So all these have 0.8s. And I need an equals 0.8. And we're worried about too low, so less than 0.8. Wait. Did the claim is too low? Oh, so we think it's, hold on. Mu equals 0.8. And I guess we're worried that it's actually higher. Does the data say the claim is too low? So, right, we think it's higher. So that one was a little tricky to think which way to go. They were nice, though. They didn't have a less than, so that was good. We're going to use students T because we don't know sigma, students T. And, ooh, we get to go do some math. When doing this one, remember to do the one quantitative variable, X bar. You're going to pull all the numbers in the first part from the sample. Ignore this 0.8. That's the hypothesized value. So let me go ahead and go. Make sure you hit mean and standard deviation there. All right. And the mean is X bar 1.26. I can write amps here if I wanted to have some context. Standard deviation is 0.42. Sample size, under a sample of 12 motors, so 12. Begin analysis. All right. Now notice I don't have any graphing on this one because I don't have any individual data to graph. Okay. And we're going to do a one sample t-test. Notice it doesn't have any others. And we said our mu is greater than, that's already in the correct direction right there, greater than 0.8. Perform inference, and there's our test statistic, 3.794. And we have a really tiny, tiny p-value, so we're going to reject again. Let's see, we're going to the right, so the shading is to the right. See, it's so tiny, they were nice. They said the p-value's over there. All right. And we reject because of significant data. There is sufficient evidence. Scroll down. Submit. Pretty sure. Yes, I did click. And you can see all the values are correct. Okay, let's do another one. A hospital reported that the normal death rate for patients with extensive burns has been significantly reduced by the use of new fluid plasma compress. Now see how we have counts here. So we have 41 out of 88. That's kind of telling you it's a proportion. We have a 1% significance level. So we're comparing the p-value to 0.01. So we need really tiny p-values. It is a proportion, so we can ignore the means, right? And the hypothesized was 60%. And we're hoping it has dropped. So the proportion is 60%. And now we're going lower. And what sampling distribution do we use? This one is standard normal, and we just go greater than. If you see a 10 there, that's fine. Okay, if you see a 5 there, it's fine. What is the value of the sample test statistic? So that means I'm already ready to use my one categorical variable because I got to put these in categories. Let me refresh this. And so we have death. And how many died? 41 out of 88. Only 41 out of 88. That's not a good way to go. Not dead. Survived. Let's say survived. So 41 out of 88 leaves 43. Begin analysis. Scroll past the data. You can see that here they had 48% died. All right, and then we come down and we're going to do a one sample C-test. And we want to make sure it matches our hypothesis right there. We want less than. Make sure you go down and then you put that 0.6. Make sure the direction's right. And there we go. Value of the test statistic, negative 2.0935, 0.0182. And we're doing less than. Always look at the alternate. So I want the shaded area on the left. This one's right. That one's too big a right. This one is two-sided. All right. And what was our p-value? Oh, our p-value in this case is actually higher than our alpha 0.01. So we're going to fail to reject. All right. We do not have a statistically significant data. There is insufficient evidence. Now we're almost to the end. Not too long. Review if you think about it. It looks long, but it's not that bad. Okay. Oh, did I miss something? Oh, what did Mrs. Silverman do? 41 of 88. I have 41, I have 43. Oh, they don't add up to 88. Yeah. Oh, good point. Always make sure that adds up to 88. I was thinking, let's put 47. Kind of glad that happened, so I can point out you can always double check your math there, make sure you're doing it right. We're doing a one sample z-test, and everything else is fine. Let's try that again. So they were both wrong, so that told me my setup was wrong. And 0. Okay, so that one, oh, that means everything's going to be off. All of these are going to be wrong down here, because we do fit reject, and the data are significant because we have sufficient evidence. Hit submit, fix that. Is that the one with the burns? That's the matters. There's the burns. And now you can see we have everything is correct. All right. This one, coffee. This is means. How can I tell? Average content is 7.20 ounces. It's not like a 7 out of 12 ounces are good or anything. It's not a proportion. This is definitely a single mean. If you're not sure, check that one, submit it. You're allowed 3 tries, so this you better get right, right? So it's a single mean, so I want to make sure I'm doing one quantitative variable. So let me refresh. And level of significance is 0.05. Right? Null and alternate. So our null, our hypothesized value, let's see, do you think the machine has slipped out of adjustment and that the average amount of coffee per cup is different than 7 ounces? Notice it says different, not less than, not greater than. So, and it's not a proportion, so it's this mean right here, okay? So what sampling distribution do we use? Well, for means, we use a student's t. We do not know sigma, we only have our sample. And now it wants me to go ahead and run it. So let me go ahead and get my mean and standard deviation. The mean is 7.2. It's the X bar, or if they say average content, standard deviation is 0.52. We have 10 cups. Begin analysis, and we're doing a one sample t-test, right? And our hypothesized value is 7. Now, I'll just show you. So I didn't change this, right? So what happens? So the value of the test statistic, if I put that 1.2163, and then let's just say I use the p-value and I forgot to change the direction, you're going to see that this one's going to be right, but that one's going to be wrong. So you're like, Mrs. Oden, let's just finish. We're almost done, kiddos. Almost done. I just want to make sure you know how to double proof that. It's like, oh, so see, if you have everything set up right up to pretty much, if you have that value right and that value right and all this right, it's fine. But if you don't have this direction correct, in this case it's a two-sided test, then your p-value is wrong. So there you go. See, the numbers stay the same. So it pretty much doubles our p-value. And in this case, when we have not equals to, we have both side shading. So both, we look at low and high values. And our p-value is pretty high, so we're definitely going to fail to reject. Oh, for insignificant data, not for significant, and say we don't have enough evidence. All right? One more after this. Here we go. Okay, last one, we have a set of data. Set of data is pretty straightforward. let's go ahead. It's means. We only have sets of data for means, and then you go ahead and refresh, and we can put raw data. So what I usually do is I just copy this, Control-C, paste that, begin analysis. So I have all my stuff. And, oh, we'll need X bar. That's our mean. So our mean is 44. And our standard deviation is 9 point. I put all the decimals. And we're doing a single mean. I know I can get this stuff right, 0.05. And we're worried about, they claim it lasts 48 months. And we're worried about less than. So mu equals 48 and less than 48. Voila. We're going to use the student's t-distribution because we do not know sigma. And we'll just check this right now. We're almost done. Submit. Make sure that my data here is correct before I start putting in numbers. The other stuff I didn't have to worry about. So almost to the end. So you can see these are all correct. Test statistics. So let's go ahead and do our test. It's a one sample t-test. And we want less than 48. Perform inference. And I get negative 1.3 and 0.1042. Looks like we're going to fail to reject, huh? And we are on the left side, so that one right there. Notice how this is a little bigger? That's because that p-value is kind of high, all right? So we're going to fail to reject for insignificant data because we have insufficient evidence. Hit submit for testing. And I could just look up here. No, it doesn't say. All right. So does it show my health thing? No, not for me. I'm in a special preview mode. And that's it. So hopefully, yeah, you're just going to have to run a couple hypothesis tests. Hopefully the Jamboard, it has way more information than I use, but it kind of talks you through everything. So copy down what you need to copy onto your cheat sheet. And good luck on your test.